60 degree, and this is 60 degree. Now in this triangle we have come to know about what is that value. Okay, that value will be 60 degree, and sum of these two, total sum of these two will be 120. Well, this is 60 degree, sum is 180 degree, but this angle 75 degree. Let me just check. So we have just calculated this 45 degree, but how? We have just taken, since angle UQW, angle UQW is equal to angle UPQ, equal to angle UPQ, while angle made by a chord with the tangent equal to alternate interior angle by alternate segment value, or this is known as angle by a chord with the, or this is exterior angle of this triangle, but in this not triangle but angle made by a chord with the tangent is equal to the interior angle, alternate interior angle. This is known as alternate interior angle. This is equal to alternate interior angle. Okay, so that is the point here. So this angle is 75, this is 75 degree. Therefore, this angle UPQ, we have calculated as 75 degree. This is 75 degree. Or angle, this implies that angle UPQ is equal to 75 degree. And this angle and the angle P, because these two angles are supplementary, so P angle PUQ is equal to 180 degree minus angle PTQ, minus angle PTQ. This is 180 degree minus 120 degree equal to 60 degree. Therefore, angle this is 60 degree. PUQ. Now we have to find out what is this angle. Therefore, in triangle PQP UPQ or PQU, we have angle UQP and UQP, which we have to calculate. UQP is equal to 180 degree minus the two angles, angle UPQ plus angle PQU plus angle, this one UPQ, we are taking UPQ plus angle QUP or PUQ, angle PUQ. Sum of these two angles subtracted from 180 degree will give us this. This is 180 degree minus 135 degree equal to 45 degree. So this is 45 degree. Hence the answer. We have to find out what is angle UQP. UQP. This angle we have to calculate. Now we have calculated this. Okay. That is the point here. This question is all about alternate interior angle. This angle made by this chord with the tangent equal to angle in alternate segment or alternate interior angle is equal to alternate interior angle. Okay, this is question number 11. We have taken this 11th question, sorry. This question was 11th. I'm sorry. This question was 11th one. I'm just doing this 11th question. PTQ. 10th I already done. So I didn't remove that 11th number. 10 number. This is 11th question we have completed. But it is known that triangles PTQ and TRS are isosceles triangles. Okay, with PQ and RS are the bases respectively. That is the question here. This question is 11th question. I'm sorry, 11th question is completed, not 10th. 10th we had already calculated. This is the 11th question we have completed. Okay. Let us take the 12th question. Now question number 12. Okay, the last one. So 11th question we have completed. Okay, by taking what is given to us, the two triangles were given, this and this, isosceles triangles. Okay, so each angle was 30 degree and vertically opposite angle was 120 degree each. If that condition was given to us, it was saying that RBS, okay, and PTQ, angle PTQ equal to twice of angle RBS was given. Then an angle UQW was 75 degree. Then we have to calculate. So this is our 11th question. Now let us take what is 12th question. The last one. Okay, so last question is again regarding two circles. Now this is a very interesting question. Let us take this again in a very fantastic manner. What is given to us in the above figure? Two circles intersect at D and G. This is point D and this is G. Okay, two circles intersect at point D and G. And angle ABD is 50 degree. Angle ABD, okay. So this is all right. ABD, now it says let me draw the figure first. Okay, and this is another triangle, and this is another triangle. Yeah, this is triangle here. Okay, this is another triangle. This is A, B. Okay, this is point B here. This is B point here. Let me join this also. AB, and this is E point here, and this let me join here. AE, and this is F point here, and this is C. ABC, D. Let me write clearly. This is D point here. Okay, C and F, F is this point, A, B, C, D, E, F. Okay. Now what is given to us and what we have to prove here? Let me further check it. I would say that in the above figure, two circles intersect at D and G. Angle ABD, angle ABD, ABD, this angle is 50 degree. Okay, angle ABD is 50 degree. Angle AED, and this angle is 70 degree. AED, and AED is 70 degree. The triangles ACF and triangles ACF, okay, and triangles CGF are isosceles triangles with base as CF. CF is the base. This side is equal to this side and this side is equal to this side. CF is the base. Okay. CF is the base. Alright. And the CF base with base CF at CF, and find angle BCG, and further says intersect at this. ACF and CGF are isosceles triangles, okay, with base at CF. Find angle BCG and angle BCG. You have to find out this angle BCG, if given that angle CAF, angle CAF is 100 degree. This angle is given to us as 100 degree. Then find out that angle. So we have to find out BCG angle. BCG angle we have to find out. Let us write here given. So here we are given what is given to us? Two circles which intersect each other, at D and G points. And taking CFS, CDF or CFS, okay, taking CF, which passes through D, as base for the triangles, for the isosceles triangles, which one isosceles triangles? ACF, isosceles triangles, ACF and CGF and CGF, yes, CGF and CGF. So CF, which passes through D, is the base for the two isosceles triangles. Isosceles triangles are ACF and CGF. They are the isosceles triangles. Okay, and angle ABD, is equal to 50 degrees, while angle AED is equal to 70 degrees. Simultaneously, angle CAF is equal to 100 degrees. Then to find what is value of ACG. To find angle ACG, this angle we have to find out. Okay, find angle BCG, okay, or AC, that is not a matter. BCG, I just say BCG or ACG or angle BCG, both are same thing, or angle BCG. This we have to find out. Solution. Now try to understand. Okay. Now this angle okay. Now what is the exterior angle of a triangle? Now this whole angle is equal to this angle. Now this is 50 degree. So this is all right. Now you see that this angle is equal to this angle. Why? Pretty. Exterior angle of a cyclic quadrilateral, this equal to opposite interior angle. Similarly, this is exterior angle of this quadrilateral equal to opposite interior angle. So this is 70 degree. I'm just telling you this is 50 degree. 70 degree plus 50 degree. This we have calculated. Okay, but these two triangles are equal. Or sorry, this is a complete angle. This is 120 degree. So this angle plus this angle, they are equal. So 60 degree. Sum of these two is 60 degree. Each will be 30 degree. This is 30 degree, and this is also 30 degree because isosceles triangle. 30 degree plus 30 degree. I'll just note down them, I'll solve them. And what about this? These two angles are also equal. This is 100 degree and each angle will be 40 degree because 80, sum of this is 80, each angle is 40 degree. This is also 40 degree. Why? Because triangle ACF is isosceles triangle. If top angle is angle CAF is 100 degree, then sum of these two will be 80 degree. So each angle is equal, so each is 40 degree. This angle is 70 degree. Final answer is 70 degree. Because we have to find out what is angle ACG or BCG, which is 70 degree. Now let us take. These questions I have just solved, but let me finally find out this by writing. Okay, so let me write them. Let me write them. What is given to us? Here BCGD, yeah, and quadrilateral here BCG and let me take EDGF and EDGF are cyclic quadrilaterals. Try to understand. Are cyclic quadrilaterals. Okay, are cyclic quadrilaterals. Therefore, angle ABD, exterior angle, for example, if it is cyclic quadrilateral, let me take cyclic quadrilateral like this. This is cyclic quadrilateral. Okay, then this angle, exterior angle, is equal to the opposite angle. Reason? Because sum of these two angles is 180 degree. Supplementary they are. Sum of these two is also 180 degree. But this angle is common, so this is equal to this. Therefore, in a cyclic quadrilateral, exterior angle is equal to the opposite interior angle. Angle ABD, this angle, is equal to angle CGD, equal to angle CGD. This angle CGD. Again, because in a cyclic quadrilateral, exterior angle in a cyclic quadrilateral is equal to opposite interior angle, interior angle. Okay, equal to opposite interior angle. As I have told you that sum of these two angles is 180 degree. This ABD plus angle BDBG, this is the straight angle, 180 degree, and this angle is 180 degrees. They are supplementary. In a cyclic quadrilateral, opposite angles are supplementary. Therefore, this angle is equal to this. This is common. Sum of these two equal to sum of these two. This angle is common, so therefore 50 degree equal to this angle. Okay, because exterior angle of a cyclic quadrilateral equal to opposite interior angle. Similarly, angle AED is equal to angle DGF, equal to angle DGF. Let me take DGF. So this angle is 70 degree. This was equal to 50 degree, and this is equal to 70 degree. So this whole angle is 70 plus 50, 120 degree. Let me write here. Solution we are finding out. Therefore, angle CGF angle CGF is equal to 50 degree plus 70 degree is equal to 120 degree. Now in this triangle, what triangle CGF is an isosceles triangle. Is an isosceles triangle. This implies that angle GCF equal to angle GFC equal to GCF, both are equal. This is equal to, now because sum of these three angles is 180 degree, this is total 120, sum of these two is 60 degree. We have to just write that. Therefore, okay, each equal to that, but angle GCF plus angle GFC is GFC equal to 180 degree minus angle this one CGF. This is 180 degree minus 120 degree. We just calculated. This is 50 degree. This is 70 degree. So sum of these two is 120 degree. This is 60 degree. 60 degree. It means this angle is 30 degree. This is also 30 degree. Each angle is equal isosceles triangle. Therefore, angle GCF is equal to angle GFC equal to 60 upon 2 equal to 30 degree. This is 30 degree angle. Now what about this angle and this? Now in this triangle, that above triangle, and in isosceles triangle CAF, we have angle ACF is equal to angle AFC. Okay, but angle ACF plus angle AFC is equal to 180 degree minus angle CAF. This angle CAF subtracted from 180 degree will give us sum of these two angles, but these two angles are equal. So this is again CF is 100 degree. This is 180 minus 100 degree equal to 80 degree. Sum of these two angles is 80 degree. Each is 40 degree because they are equal. 80 degree. Therefore, angle ACF equal to angle AFC. Both are equal, so and sum of them is 80 degree. So each must be 40 degree. This is 40 degree. This is 40 degree. So sum of these two angles, 40 plus 30, is 70 degree. Only this angle we have to calculate. We have to calculate what is angle BCG. BCG, this angle, whole angle. Therefore, angle BCG. Therefore, angle BCG. Therefore, angle BCG is equal to angle ACD plus angle GCF plus angle GCF, and this is 40 degree, ACD 40 degree, and GCF is 30 degree. This is 70 degree, and this is the answer here. So question number 12 we have obtained as 70 degree. This is the answer. So answer of question number 12 is this angle we have to complete angle BCG or ACG, Angle is 40 plus 30 degrees, 70 degrees. Okay, that is the solution of this question. Question number 12 we have completed. Hence the 12 questions are completed. Okay, that is the answer for this. So these 12 questions are okay ended, and that ends the lecture series of circles. All the 4 lecture series I have taken here, which have included most of the questions of different type. So these queries are from students side. They have asked me very difficult questions. These are for them. Okay, and but they are solved up to now. So I think the basics of circles will be clear, will be clarified then. That I assume, or I just I'm assured about, or I'm sure about. Okay, so because all the basics of the circles now up to this lecture series is clear. Okay, so all these questions I have completed, and I hope that all the basics are clear of the circles regarding competitive examination, because competitive examinations includes, as I have told you number of times, triangles, quadrilaterals and circles. Most of the questions are coming on in geometry section. In geometry section, questions based on triangles, quadrilaterals and circles are mostly appearing. For that purpose, I have completed this one. Okay, this ends the lecture series of circles. Okay, then see you in the next lecture series, which will be on 3-dimensional geometry or solid geometry. Solid geometry we will take in the next lecture series. Okay, see you.